The Noyce program is a program where we give students fiscal support, and we try to develop a community of learners to help those teachers when they go into the field to be better math and science teachers. And we do that by having regular meetings and by having these students connect with each other and having the more experienced Noyce scholars interact with our new Noyce scholars, some of which are undergraduate students. And by developing that community and fostering that community, we hope to be able to impact STEM education in the K-12 schools.
And one of the great things about the Noyce program is that we get to have little mini conferences on a regular basis where we get together and talk about what we're doing in the classroom, and I really love that because there's a lot of tips and tricks for classroom management, there's good ideas for projects, you know, the opportunities we have here too at Sonoma State to do things like the Maker programs. That has all been a huge influence and has helped me be a better rounded teacher.
We look at their achievement in the sciences in their major. And so we have undergraduate students that are coming in from juniors up. And then we have people in the credential program. And now that we've been around for 5 years, we have a total of almost 55 Noyce scholars, and they are from undergrads all the way, been teaching 4 years.
But I also find that working with my other Noyce scholars gives me a bigger breadth of knowledge. There's another Noyce scholar, Kelly Kennedy, over at Sonoma Valley High, who's also teaching engineering, and I had the opportunity to go visit her classroom on one of my off days, and that really helped me get a better sense of what I could do with in my classroom.
We have to have a very different way of having our STEM teachers connect with the students and have a different kind of activity, different kind of pedagogy that our teacher candidates will work with their students. And so things like having our teacher candidates actually engage our students in inquiry, letting them be citizen scientists, it was an example of this, where they actually have to go out and collect data and use data as part of their learning. But that's the kind of instruction that we're trying to support here.
So it's really important for a teacher to engage students by first engaging them on a personal level and being their bridge from content to student and to realia of their real life. I do that a lot, but with project-based learning. I was able to go to a seminar for project-based learning, and throughout this year we've been able to do a lot of really fun projects. The kids first did a project about called Science and Social Media, where they had to find and research a claim that was made on social media and either debunk it or support it with credible evidence. We just wrapped on a project called It's Your School Pool. We just had a new pool put in, and the prompt was to research and propose the best water treatment option for Novato High's new pool that took into account various factors, including cost and health and maintenance. And that was really interesting because they actually got to sample our pool water. They designed and implemented their own lab experiments, and then later presented our pool should be bromine or chlorine or saltwater systems. And through that, they were able to learn about chemical equilibrium and pH and all sorts of solution chemistry that might not have been as accessible to them otherwise.
Working with the students, I have done the dry lecture. I've been that person. And I've been the lecturer that's strict and make sure that they're sitting in their seat and that they're doing their problems out of the book. And like you mentioned, the engagement, although maybe they're doing what they're supposed to be doing, they're not learning. They're memorizing a process that's going to leave them. So when we get them working on a project that integrates all of these, the math, the science, the engineering, it's engaging to the point where they come to me with questions. And I mean, isn't that science in general? Asking questions and finding ways to figure them out. You're not going to have too many kids coming to you after a 15-question worksheet saying, "Ooh, what happens if X is squared in this case?" It's just not as exciting. So it's wonderful to get them engaged to the point where they will see the value in it.
I'm really excited about the NGSS, the Next Generation Science Standards, because it focuses less on reciting content and instead on developing critical thinkers. And I was really lucky to be part of a program that allowed me as an educator to develop as a critical thinker and really reflect on what practices am I doing and how do these meet our new disciplinary core ideas or cross-cutting concepts that the NGSS framework lays out. Instead of just focusing on meeting standard A, B, C, and D, it's really evaluating students on their ability to think like a scientist.
STEM innovation is really going to depend upon a diverse talent pool being behind the STEM ideas that go about making change. And so when we think about who should be part of that innovation, it's got to be everybody for it to really be the innovative kind of advancement that's going to tackle some of these really challenging, interesting, and often very fun problems that we face.
It's really important in science that students see how what they're learning applies to their everyday life. So giving them topics where they can study chemistry in their world, in their pool, in their home, in the products that they use every day, in the social media that they use, that's how you build engagement, and that's how you get the most student involvement. I found that students are most successful when they're doing projects, as opposed to doing reading out of a textbook or watching lectures. We do very little of that. It's student-centered, it's student-driven, and there's a lot of choice, which allows them to really study anything that they want. Of course, when you do that kind of work, you have to build in the scaffolds and build in the check-ins. And when you do things like projects or flipping your classroom, you have an hour with a full class every day to check in and see where they're at, see what they need, and to make that relationships with them and the relationships with science for them.
I hope that students in my classroom take away a sense of pride of what they've accomplished, and also the sense of what's possible for them. One of the best things about this engineering class is the exposure it's giving to my students for a breadth of careers and possibilities. I have one girl that during the robotics project learning how to code, she is so excited about coding and is currently looking for a summer internship or additional classes she can take to learn more about how to computer program. I think it really might be a viable career for her.
I hope that the Noyce scholars teach us, right? So some of the initiatives in place in single subject preparation program where we have our faculty connecting with teachers, connecting with teacher candidates through the different professional development model of of student teaching that we're proposing. I think we will learn from our Noyce scholars too, and I think that we need to be part of that community as well.